All right, welcome back. We are on part 2 of module 6, and what we're going to do is talk about standardizing a normal random variable. Now, what we used to have to do with information was change it using the z-score so that the mean was 0 and standard deviation was 1. Our technology has changed enough that we don't need to do that anymore. So once again, I want to put that. Let's just jump into it. That'll be the easiest way to do this. Assume the drive-through times at a local burger place are normally distributed with the mean time spent in the drive-through 168.5 seconds and standard deviation of 29 seconds. Part A says, what is the probability that a randomly selected car will get through the drive-through in less than 100 seconds? So let's start. And here we have 138.5. Less than 100 seconds, that means we are here. So we are looking for normal CDF. Now, this is going to be negative. Remember, it's a big number because we're going up to negative infinity here. Up to 100. And I still have to put the mean, 138.5. And the standard deviation, which is 29 seconds. And here, I'm going to go to distributions, normal CDF, negative 99999, upper is 100. Now I have to change the mean and the standard deviation. 38.5, standard deviation of 29. Now, those of you that don't have this interface, it'll look just like this when you type it in, or like this. So 0.0922. I go to 4 decimal places. So there's about a 9% chance that I would spend less than 100 seconds in this drive-through. Let's try B. B says, what is the probability that a randomly selected car will spend more than 160 seconds in the drive-through? Well, that's going to be here. 138.5, more than 160. This is 160. This would be normal CDF. CDF of, now we're starting at 160 and we're going off to a big number with a new mean and standard deviation. Normal distribution. Now the lower is 160, the upper is 99999. The mean and standard deviation are the same. That's nice. So there's about a 0.2292 is the probability, meaning about 23% chance that I'll be in line more than 160 seconds. Part C. The proportion of cars that spend between 2 and 3 minutes. Now I need to be extra careful here. Everything has been in seconds so far, including the mean and standard deviation. Here. So 2 and 3 minutes means that I'm between I'm between 2 minutes, which is 120 seconds, and 180 seconds, which is 3 minutes. This will be normal CDF, 120 to 180, 138.5, and 29. 20 or 80. And those are still the same. So a much better chance that you'll be between 2 and 3 minutes. All right. Next up. So we have the reading speed of 6th grade students is approximately normal with a mean speed of 125 words per minute, standard deviation of 24 words per minute. What is the reading speed of a 6th grader whose reading speed is in the 90th percentile? Now, if you remember, 90th percentile means that 90% of the students read slower than this person does. The top 90th percentile is going to be somewhere over here. Now, this one's going to be slightly different because now we're given the area. So now we're going to be using inverse norm. And the area to the left is our 0.9. But now we have a new mean and standard deviation. So now we're doing inverse norm. Because we're given the area in this case, we're looking for a z value here. Area to the left is 0.9, 125, and 24. If you don't have the previous interface, it'll look something like this. This is about 155.76 words per minute. So meaning if this 6th grader can read 155.76 words per minute, that means 90% of the other 6th graders read slower than that. B, determine the reading rates of the middle 95% of all 6th graders, and what are the cutoff points for the usual and unusual? So we want the middle 95%. So we're going to have 2 cutoffs, a too slow and a too fast. So remember the area to the left here, because there's 5% left over, that means half of it, that missing 5% goes here. So 0.025, and also here, 0.025. And remember, it's area to the left. So area to the left here is 0.025. Mean and standard deviation are the same. That's nice. So the lower limit and of 0.025, comma 125, comma 24, to about 78 words per minute, I'll say. So that's the lower bound. And the upper one is going to be inverse norm 1 minus 0.025, 125, 24. So inverse norm 1 minus 0.025, mean and standard deviation the same, 172. This is words per minute. So 95% of the students read between 78 and 172 words per minute, is how we could interpret that. Part C. Find P sub 20. So the 20th percentile. So again, percentile is always below. So 20th percentile is going to be somewhere over here. So this is 0.2. Let's see what we got. Point 2. Mean standard deviation the same. 104.8. So this is inverse norm of 0.2, 125, 24 becomes 104.8. So if a student, a sixth grader, reads less than 104.8, they're in the 20th percentile. A better way to word that is a student who can read at 104.8 words per minute has 20% of the other sixth graders that read slower than they do. Part D. In the third quartile. Now, I want us to remember what quartile is. Quartiles break everything up into fourths. First quartile, mid quartile. And so this gives us, just a quick review, 25%, 25%, 25%, and 25%. So the third quartile is going to be here. So this means 75% is below. Which means inverse norm of 0.75, mean standard deviation, (141.19). This is words per minute. So if a sixth grader reads at 141.19 words per minute, that means 75% of the other sixth graders read slower than that.